Good morning, students. In last class, we discussed about what we mean by atomicity, and in this session, I want to discuss various type of what we call as isolation, other properties, remaining properties in acid properties called what is called as isolation. Next, consistency, and last one is durability. We have remaining three properties in acid properties called consistency, isolation, and durability. See, already you know about the consistency. That is, it is correctness. Okay, it means the integrity constraints. That is, when consistency means it is nothing but it is the integrity constraints whatever we are using, integrity constraints must be we have to maintain must be maintained so that database database is in consistent. Okay, when it is consistent means uh, before and after transactions. Okay, so it means that consistency is when the integrity constraints must be maintained so that database is inconsistent, and when it is consistent means before and after transactions. Okay, so that's the thing we have to discuss. Okay, next, what if you give an example means when you say that particular mm, when you say that consistency means you say that if we are taking two transactions called sum of a comma b. Okay, before sum of a comma b is equal to sum of a comma b after transactions. Okay, so then we can say that is before transaction is equal to after transaction, so that we can say that it is a consistency. Already the introduction of what the transaction management is explained with an example. Okay, so if you have any doubt, see particular basic introduction of what is called as your consistency example. Okay, now coming to another property called as isolation. Okay, what do you mean by isolation? Okay, so the isolation means whenever you are doing transaction, the transaction will be isolation. Whatever you are doing a transaction, the transaction must be isolation. That is, what do you mean by if you say isolation means until you are doing one transaction, okay, you are doing one transaction until one transaction is completed. Okay, another transaction has to start. That is called as isolation. Okay, that is, it should not show to other transaction. Simply we can say that another transaction means it should not visible to, it should not show whatever the process to another transaction. It should not another transaction. This is called as isolation. That is, until one transaction is completed, another transaction has to start. That is, in between the process, it should not show to one transaction to another transaction. Okay, for this example, we will take one example. What do you mean by isolation means we will discuss with an example. Okay, right, what do you mean by particular okay, we have a transaction 1 and we have a transaction 2. Okay, we have a two transactions, T1 and T2. Okay, we have a two transactions called T1 and T2. Now, coming to this, we have a two transaction. For example, A has, for example, you take 500 rupees and B has 200 rupees. This is the basic transaction. Before transaction of two accounts, A has 500 and B has 200. Now, coming to this total we have before transaction means 700. Okay, now you are taking read of A, so that automatically 500 will be read to this particular whatever you call as account A. After that you are following A minus 100, A minus 100. So this is the whatever called as reading means, already you know that, debiting. Okay, next transaction process, transaction is happening, and followed by, after that, when you are saying that write off A means automatically it is created. So that if you take this is as a, if you take this is a 500, and now whenever you say that write off A means, it will be what means, now the transaction is 400. Okay, meanwhile now you are taking a transaction called read of A. Here you are taking read of A. If you saying here read of A means total amount is 500. Now if you are saying again read of B, this is called as you are doing two transactions. This is the important. You are doing two transactions here. Okay, read of A and read of B. You are taking, what I am saying that until one transaction is completed, another transaction has to start. But whenever you are saying read of A, now you are saying that second transaction read of B means it take 200. I hope you understand. Now, if you say that read of B, this is the same transaction, read of B. Now, already B has 200. Now, you are taking read of B. Read of B. Now, you are B equals to, you are debiting amount of B plus 100. B plus 100. Next, once again, write off, you say that write off B means automatically it will be 300. Okay, right. This is the initial is 700. Next, after transaction, B consists of 300 and A consists of 400. So this is the 700. So in between transaction, another transaction is happening, will get different data. The data used in one transaction should not used by another transaction. So here, like in between read of A and read of B. See here, when you see here, now finally you have the amount of B has here, see the amount of A consists of A plus B is equal to 700. Now you get a difference. A plus B equal to 700, because here A consists of 400 and B consists of 300. But when you come to here A plus B, if you are saying A plus B, here is 600. There is a difference. See, I hope you understand the concept. So once you are doing the one transaction, you can't do the starting of another transaction. If that is happened, so there will be a difference of the two transaction. Here the amount of two particular persons is 600, where here is 700. There is a difference between these two transactions. I hope you understand the concept of isolation. The isolation concept is, it means we can say that the transaction will be isolation until one transaction is completed. That is, it should not show to another transaction. If you see this example, we have a transaction with another transaction is happening, so that we will get a different data. So the data used in one transaction, the data used in one transaction should not used by another transaction, like in between read of A and read of B. I hope you understand the concept. Here you are taking the read of A is 400. Here you are taking the read of B is 300. Okay, I hope you understand the concept. Here you are reading amount of what the amount you are reading. Here you are reading. Here we are reading 300 amount. Here we are reading the A transaction is reading 400. Here the reading is 300, but here the reading is 400 and reading is 200. I hope you understand the concept. Okay, this is the concept of isolation. Okay, next, last concept is, you have another concept called as durability. You have durability. That is, what do you mean by durability? Means all updates you have, whatever doing by the transaction, all the updates that you are doing by the transaction must be permanent. I hope you understand. Whatever you are doing this transaction, whatever doing this transaction, whatever doing another transaction, all the transaction must be permanent. That is, permanent means what? You know that what do you mean permanent means? I know. I hope you understand what do you mean permanent means. If you say it is a commit, when you say the commit statement, then it says that it is a durability. That is, transaction is done. That is, transaction is done. Then it makes permanent. It is used when you there is a, if you say that there is any power loss is happened. That is, any power loss happened. That is, power loss is happened means defaultly system will rectify. Okay, system will rectify. Otherwise, until you, that is a person, until you changes the values in the database, it will not erased. That is called a durability. It will not erased. This is the important point. Until, this is the important point. Until you changes the values in the database, it will not be erased. Sorry, it will not be erased. So default, if there is a power loss, means the system will defaultly go to the abort state and automatically rectify the clean the buffer values by means of the permanently partially committed. If there is any, until any person changes the values in a database, it will not be erased. That is called as durability. I hope you understand the properties of all the acid properties called atomicity, consistency, isolation, and durability. Okay, finally, if you take the atomicity, means just we can say that transactions either has to happen or nothing has to happen. Some summary of your acid properties. Transactions either all are happened or nothing will be happened. Consistency means only whatever you saving the data, only that is a valid data, only valid data is saved. Only valid data whatever you're doing is saved. Valid means what? Valid means sum of AB equal to sum of AB before transaction equal to after transaction. This is called as consistency. Next, Transaction is nothing but if you are doing two or more transactions, it do not affect each other. Do not affect each other. It should not be affected with each other. And last one is durability, means okay, written data, whatever you are writing, it will not be lost. That is, user change, until user changes, it will not be, it will not modify. Okay, this is the summary of acid properties. I hope you understand the concepts of atomicity, consistency, durability, and isolation. I hope you understand the all four whatever you are saying, that uh, properties of acids are completed. I hope you understand the basic scenario of transaction management. Okay, so almost all 40% of 50 unit is completed. Now, so in the next session, or in that next session, automatically we will discuss about various consistency, concurrency controls and deadlocks. All are automatically. I think you understand these concurrency control and the deadlock, serializability, all comes in operating system, but I will discuss after this session. Okay, thank you all.